Okay, welcome to section 3-3. This is the slopes of lines. The picture in the background has absolutely nothing to do with slopes of lines, but it is turning fall, so I thought this was a nice picture for us. Of all the lessons in the book that I would feel comfortable not being there teaching you, it's going to be this one. The class is very good at algebra, and this is strictly algebra, with just a slight bit of geometry in it. So without further ado, let's go ahead and get into section 3-3, slopes of lines. You guys remember what slope is. It's the rise over the run. And then for any 2 points A and B that have coordinates x1, y1 and x2, y2, the slope, the symbol for which is m, is calculated by the difference in the y's over the difference in the x's, where difference is our math word for subtracting, so y2 minus y1 over x2 minus x1. Now, a couple of things about that formula. If you learned it y1 minus y2 over x1 minus x2, that's fine. It doesn't matter the order in which you subtract. And if you want to say that point A has coordinates x2, y2, and that point B has coordinates x1, y1, then that's fine too. The important thing is if you're going to subtract with this number first, then you have to subtract with this number first. Otherwise, you're going to get the sign wrong. And that's what I'm explaining down here. M is a symbol used for slope. It doesn't matter which point you call A or B. The important thing is that if you use the y coordinate of one point first in the equation, you must use the corresponding x coordinate first. Otherwise, you get the sign wrong. So if you learned it differently in a different order, that's fine. Just again, if I use this one first in the equation, then I have to use this one first in the equation, or the signs backwards. The slope is just rise over run. So you actually have homework problems like this. It's a little embarrassing. We're going to find the slope of the line that goes through there. So I'm not afraid of negative numbers, so I'll do minus 3 minus 4 over 2 minus minus 4 gives me negative 7 over positive 6, which you can rewrite as negative 7 over 6. Those are the same. And I don't care which way you leave it. Now, just to verify that it doesn't matter which point I use first, let's go ahead and do it for fun. Positive 4 minus minus 3 over negative 4 minus 2 gives me 7 over negative 6, which is negative 7 over 6. Hey, it worked. That's a good thing. And we probably would want to change this one to this, because it's bad manners to leave a negative sign in the denominator. I would take off, but, then I would do this instead. So, all right, you guys can all do that. Now you're going to have to do some graphing, and that means graph paper tonight. Let's recall how to do it. We remember that slope is rise over run, so let's graph the line through the point negative 1, 2, and it has a slope of negative 2. So that means m is equal to negative 2. And remember, I can write that as a fraction as negative 2 over 1. So the first thing you do is you plot your point. I'm at negative 1, positive 2, so I'm going to go over 1 this direction, up 2 that direction, and plot my point. Now, slope is rise over run. So I'm going to rise negative 2, 1, 2, and run positive 1. Rise negative 2, run positive 1. Rise negative 2, run positive 1, over and over and over again. That's how I'm going to get my line. Now you can do it the other way. If you want to rise positive 2, 1, 2, and run negative 1, you can do that. Now that should end up on the line. I don't know how I got off with this, but that's how it works. And you plot 3 or 4 points and you can draw the line. Now, as it notes right here, it's just a coincidence that I went to the origin. Not every line goes to the origin. I just happened to make one up that did. But don't think that you have to plot the point and then go through the origin. That's not how it works. You're going to follow the slope and the rise and the run of that. There are a couple of special cases of slope. If you have no change in the y coordinates, then the numerator is going to be 0. So the slope of the line is 0. And if the slope or the rise part of it is 0, that means it's going to be horizontal, flat. So just like you look out on the horizon, you can remember horizontal. Now, if the x coordinates don't change, what's going to happen is you're going to have division by 0. Division by 0 is not good, so we say that's undefined. And those type of lines never get to run anywhere. They're only rising. And so those are called vertical lines. And so you want to think vertical. I couldn't think anything clever like horizon and horizontal, so just think vertical to remember vertical. Horizontal lines look like that, and vertical lines look like that. And vertical lines and horizontal lines are perpendicular. They'll form right angles. So these are the 4 types of slope that you can have. If both the rise and the run are positive numbers, you get positive slope, like this red line, which, remember, this is the x-axis and this is the y-axis, so that as x increases, y also increases. Now, if one of the two are negative, then you get negative slope, like we did in our example. So that means as x increases, y decreases. And then the 2 special cases we just talked about. The horizontal, when you have no change in y, or vertical, where you have no change in x. So that's what the 4 types of slope look like. Now, we've talked about parallel lines as being coplanar lines that do not intersect. Well, that means that they rise and they run at the same rate. And if they rise and run at the same rate, that means their slopes are the same. So if 2 lines are parallel, their slopes are the same, and we remember it by saying m1 equals m2. Perpendicular lines form right angles. And we know that by that little box right there is how we know that they're perpendicular. And their slope has a special property as well. And there's a couple of different ways to remember it. Some people like to remember that their slope, the product of their slope that is -1. And that's not how I always remembered it. I always remembered it as being, this says negative reciprocals. It's probably not the best terminology. A better way to say it would be opposite reciprocals. But what you do is you flip it and change the sign. That's a better term, opposite reciprocals. So if I have 2 over 3, then perpendicular to that's -3 over 2. If I have -6, then perpendicular to that's +1 over 6. You flip the fraction and you change the sign. They're opposite reciprocals. So here's an example of what your homework might look like tonight. Find the value of x so that the line that passes through x5 and 12,2 is perpendicular to the line that passes through 0, 1, and 2, 7. So a couple of things to point out. Perpendicular, so we know the slopes are going to be opposite reciprocals. So what we want to do is to find the slope of this one, and then do the opposite reciprocal to find m2. And let's see how we do that. The slope that goes through those 2 points, we'll do 7 minus 1 over 2 minus 0 gives me 6 over 2, which is 3. No worries there. Or 3 over 1, you can say that if you want to. So since you want perpendicular, we're going to choose opposite reciprocal. So this is 3 over 1. So I'm going to change the sign and flip the fraction. So the slope of the second line is -1 over 3. Now recall that the slope is the difference in the y's over the difference in the x's. So I know the y coordinate of that point, the y coordinate of that point. I know the x coordinate of that point. This is the x-coordinate I'm looking for. So I just plug those values into the slope formula here. So 2 minus 5 over 12 minus x. Then we're going to do a little cross multiplication. If you like algebra, this is one of the sections for you. Negative 1 times that's going to give you x plus 12. And then 3 times negative 3 gives you negative 9. And huzzah, x is equal to 3. You can rewind that if you need some more time to get that. But we're going to keep going. Huh. And we got to the homework slide. That was easy. Alright, so that's what time it is when I recorded this. I don't know what time it is now because I don't know what time you're watching this. But you do have to do these problems. And don't forget to use graph paper for all the graphing. Alright, have fun.